Problem 2. Pulleys in an inclined plane. We have been given an inclined plane which makes an angle theta with the x-axis. There are a couple of masses, m1 and m2, on the inclined plane, and m3 is hanging by the pulley. So the first step in any of these problems is to draw the free body diagram of all the entities involved. First, take the strings. Now we know that the string is taut, it is tight. That's the ideal situation which we consider. And a taut string exerts force in the form of tension on the string. So let's take the string which is going by the pulley. This string will exert the force. Let me have a different color here. Let's take, this will exert the force T1 on M2, and the same tension exists the other places also on the string, that is T1 acting on M3 in the upward direction. The string always pulls the masses which are attached to it towards itself, so to speak. And every action has equal and opposite reaction, that is by the Newtonian's third law. So the same force acts on this pulley also, T1 in this direction and T1 in this direction. Let me color this so to make it more aesthetic. Similarly, we do the analysis for the string connecting M1 and M2, and here it is T2 acting on M1 in the making M1 move towards M2. That's how the tension in string act. And M2, for M2 it acts in the opposite direction, same T2 again. What are the other forces? Let's see now M3. It's very easy. M3 is not touching the plane, so only one force acts now. Sorry, let me take a darker color. And this is M3 times the gravitational acceleration due to gravity, so M3g. What about M2? M2 first gets a force from the inclined plane, so that is the normal force, and the normal force is normal to the surface. So if the surface is like this and an object is placed in let me draw it for M2 separately. So M2 is kept like this. It has a force T1 in this direction, a force T2 in this direction. The normal will act on M2 perpendicular. Perpendicular is also, the word normal is used for perpendicular. So the force will act like this. Call it N2 to just rhyme it with M2. Okay. What is the other force which is acting on M2? The acceleration due to gravity. And that acts from the center of mass of M2 in the downward direction. So note that here normal and the force due to gravity are not in the straight line. This will be M2g. Let's see what happens for M1. Exactly the same analysis. M1 is also lying on the inclined plane. The force T2 is acting in the upward direction. It has the normal, call it N1, and the force due to gravity, call it M1g. So these are the free body diagrams for this problem. Now note that all the masses are connected by taut strings, and we know when this is the case, all of them have the same acceleration. Without any loss of generality, assume that the mass M1 and M2 are moving down the incline. And there's no loss of generality, because if the acceleration turns out to be negative, then we'll say both of them are moving up the incline and M3 is moving down. So we can assume safely that M1 has an acceleration A down m2 has an acceleration a down the incline, and from that same token, a is the acceleration of m3 away from the direction of gravity. Now, for mass m2 and m1, we have to simplify the free body diagram so that we can write the force equal to ma equation. And we have already done in the class. We will want to find the component of m2g, which is parallel to the incline, because that will actually be accelerating the block, and we'll find the force acting on m2 perpendicular to the incline, which basically will cancel with the normal force. And we did in the class, this force is m2g, because if this is the angle theta, then this is also theta, so this is m2g cos theta, and this is perpendicular component is m2g cos theta, the parallel component is m2g sin theta. On the similar token, the perpendicular force and parallel force can also be found for m1, and this will be m1g cos theta, that's the perpendicular force, and m1g sin theta. Alright, so now we just have to write the acceleration equations. Note that for both m1 and m2, there is no motion perpendicular to the incline, so n2 is equal to m2g cos theta, and n1 is equal to m1g cos theta. Now we'll write the F equal to ma equations for everyone. So for m1, it would be total resultant force. Acceleration is in downward direction, so total resultant force will be t. Sorry, there's no t2 for the m1. It will be just m1g sin theta is equal to, I beg your pardon, m1g sin theta, and there's an opposing force of t2 equal to m1a. Then for m2, it will be t2 plus m2g sin theta minus t1 is equal to m2a, and for m3 it will be t1 minus m3g equal to m3a. If we add all these equations, we'll get m1g sin theta plus m2g sin theta minus m3g is equal to m1 plus m2 plus m3. A, which implies acceleration is m1 plus m2. I can take g common, and then m1 plus m2 sin theta minus m3 upon m1 plus m2 plus m3.